David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, adding and subtracting radicals. Now this process is fairly similar to combining like terms when we were doing that in our initial algebra section. So let's do a quick little example here. I have 2 root 3 minus 4 root 5 plus 3 root 3 plus 9 root 5. So our like terms are our roots. So root 3 and root 3. These two I can combine. And it kind of makes sense. I have 2 root 3's here, and I have 3 more root 3's there. So that makes 5 root 3. And then for the root 5's, I have minus 4 root 5's, but I have a plus 9 root 5's. So this is going to be plus 5 root 5. Okay? So that's how these 4 terms combine. If you'd like to pause the video, you could try this next one. 7 root 5 minus 3 root 7 plus 12 root 5 minus 9 root 7. Give it a shot. Okay, let's see how you did. My like terms are my root 5's. I have 7 of them and 12 more, so that's 19 root 5. And then I have a negative 3 root 7's and a negative 9 root 7's, so that's minus 12 root 7. Okay? Now this one's a little bit more tricky. Give the video a pause, see what you get. Okay, let's take a look here. I have 18 root 11's and minus 1 root 11. So that's 17 root 11. Now this one, this is a little tricky. I don't have any other root 9's, so there's no combining that I can do. But root 9, that's 3. 9 is a perfect square. So this is 9 root 9, which is really just 9 times 3, which is 27. Do I have any other root 13's? I do not. And I have my minus 10. Remember, I combined my root 11 with the 18 root 11's here to get 17. So now I just have my 27 and my negative 10. So I'm going to do 17 root 11 plus 7 root 13. Now let's combine. 27 minus 10 is going to be plus 17. Okay, let's do some more tricky problems. Root 48 plus root 27. Yikes! These are different roots. How could I combine them? What you're going to have to do is go back to simplest form, that's the last lesson, and convert these into simplest form and see what happens. 48, let's factor that into perfect squares. So 2 times 24 is 48, but that's not going to do it. 4 times 12, that's good. 4 times 12, but I think we could do even better. What's 48 divided by 3? 16. So this would be 3 times 16 plus, now 27 is 3 times 9 plus root 3 times 9. Now that's looking good. And you'll see in a second why I think that. But just to summarize, 48 factors into 3 times 16, and 16 is a nice big fat perfect square. 27 factors down into 3 times 9, and guess what? 9 is also a perfect square. So let's take a look at this first one. The square root of 16 is 4, so that comes out. 4 root 3. And then 9 is a perfect square, the square root of which is 3, so that becomes 3 root 3. And guess what? Now we can combine these. I have 4 root 3's plus 3 root 3's, so this is going to be 7 root 3. Now, that's kind of cool. You'd never guess that this big thing would end up being simply 7 root 3. But it is. If you want to pause the video, try this one. Different numbers, same idea. Okay, let's take a look. This one has a nice factorization with perfect squares. because 2 times 36 is 72. So this is going to be root 2 times 36, and that's a nice perfect square. We're going to use that in a minute. Plus, now 2 times 100 is also a nice one. I'm sorry, 200 is also a nice one because it's 2 times 100. So we just do 2 times 100 there. Now you can see why we did that, because I have a 2 that's going to stay under the root. 36, the square root is 6, so that comes out as 6 root 2. And 100 comes out as 10. So that's 10 root 2. And this whole thing is going to be 16 root 2. Okay? So that got quite a bit more simple. Okay, you're going to get problems that are written like this. It's going to say something like, show that root 8 plus root 18 is the same thing as root 50. So what we're going to do is we're going to work each side of these, put them in its simplest form, and see if they're equal. What's root 8? Root 8 is root 2 times 4. Root 18 is going to be root 2 times 9. I'm just going to keep working this side first. 2 times 4, 4 is our perfect square, comes out as its square root. I'm going to have 2 root 2. This is the real same, similar thing. 9 is a perfect square, comes out as its square root. I'm going to get 3 root 2. This is going to be 2 root 2 plus 3 root 2 is going to be 5 root 2. So let's take a look. What does 50 do? 50 is root 2 times 25. And 25 is our perfect square, comes out as a 5, and we get 5 root 2. So yes, it works. Root 18 plus root 8 is the same thing as root 50. You'd probably never guess it by looking at this, but once you master simplest form, combining and adding and subtracting square roots, you'll see that it is. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.